Welcome to Satya channel. Today we are going to see the first video on software testing. Thanks for watching the video. Subscribe for more updates. Leave your valuable comments and likes. Click on the bell button for notifications. Please share the video if you like the video. Introduction to software testing is the topic of the day. Why is software testing needed? In the present day world, we are surrounded with software applications and products in our everyday life. Refrigerator, laptop, cell phone, mobile applications, automobile industry, medical industry, televisions, and so on are filled with software, and hence software testing is needed to ensure that the software is working properly. First, suppose if software is not tested. In spite of testing the software, many problems are encountered. First, suppose imagine the software is not tested. We would end up in more and more errors and bugs in our daily life. And hence, the software testing is required. The purpose of software testing is to ensure that the software application and product are defect-free or bug-free to the end user to the maximum extent possible. We cannot guarantee 100% bug-free product. Let us see who coined the word art of software testing. Art of software testing was coined by Glenford J. Myers, who also wrote the book The Art of Software Testing. He was the first person to head the software testing team in IBM and laid principles and foundations to software testing. We shall see the principles of software testing in our next video. Myers' implementation reduced the software errors to a drastic level, and the team was very successful in delivering out the productivity. What happens due to software bugs or errors? This results in loss of money. An automobile example is Nissan had to recall over 1 million cars from the market due to software failure in the airbag. Another classic example is the Y2K problem in the software. When year was coded during the initial days, year was also coded as a 2-digit, like month and date. DD and YY was also a 2-digit code. In the late 1990s, people realized that the year had to be coded as a 4-digit code, because after 2000, 1900 would also be shown as 00 and 2000 would also be shown as 00. Many programmers were recruited to solve the Y2K problem. Why is it called Y2K? Y is for year and K means 2000, so it's Y2K. Loss of reputation, death, injury and penalties. In the year 1985, due to a software bug, a radiation therapy machine delivered high dosages to patients, resulting in the death of 3 people and critically injuring 3. Loss of human life. The China Airlines crashed due to a software bug, killing 264 people. The stock market bug. In the year 2015, Bloomberg terminal crashed in London, affecting more than 3 lakh traders on the financial markets. The satellite launch failure was the costliest software bug, resulting in the loss of $1.2 billion in the year 1999. The aim of software testing is to ensure that the hidden bugs are found in the software. This is a classic example of how a customer wants a product and how it is designed. Same rule applies to the software as well. Now let us see some more examples. The client wants the house to be designed in this way and the end product is designed in this way. The client makes a requirement that he wants a bridge with something fascinating below it. The client expects the bridge in this way and it is designed in this way. So, verifying and validating the product is a must. Software testing is done for many applications and products. Software testing ensures that the end product is bug-free. Let us see the definition of software testing. Software testing is a process of finding the bugs in the software. The intent of finding the hidden bugs and errors in the software is the purpose of software testing. After the software is tested, it is ensured that the software is defect-free to the maximum extent possible. Goals of software testing. The first one is to find the bugs, defects and errors in the software product or application. The second one, to check if requirements confirm. The third one, test if the software is fit for use. The fourth one, check the quality of the product that has to be given to the end user or the customer. Now let us see what are the important steps in software testing in order to ensure the quality of the product. The first one is verification, the second one is validation. There is a difference between verification and validation, which we shall see. Verification helps us to determine about the quality. The outward appearance is seen in verification. The look and feel is felt in verification. For suppose I have a pencil and this pencil has to be tested. I just check the outward appearance of the pencil and ensure that are we building the product right? Does it look like a pencil? The way an appearance gives a pencil feel or not. So we are not testing the product, but we are just only seeing the product. So it's called static testing. Let us take a login screen. The client has asked us to design a login screen. So when we do the verification, we just check if it is looking like a login screen or is it looking like an exit screen or an inbox screen. If it looks like a login screen, our verification is correct. If it looks something different, then the verification is wrong. So verification is static testing to ensure are we building the product right. Verification is done taking the requirements as the basis. The client gives the requirements, this is what I want. So based on that, this verification is done. Validation. Validation is the second step which is done after verification. Evaluation is done in validation. In validation, we check are we building the right product. For suppose there is a pencil, we take the pencil and we write with the pencil and check whether it is writing correctly or not, whether the intended darkness of the pencil is being reflected or not. So it is dynamic testing because we are writing and testing it. In the same way, if there is a login screen, we have already verified whether it's a login screen or not. Now we have to validate. So we give various other details, the login details, and then evaluate this. So this is validation. Validation is evaluation of the product to check that the software meets the customer requirements and expectations. After we validate the product is guaranteed of quality. V&V is called as verification and validation. The differences between verification and validation. The first one, verification is static testing. Physical aspects are judged. We have seen when we take a pencil or a login screen, only the physical aspects are judged in verification. Validation is dynamic testing. We write with the pencil and we check it. Execution is done. So in the login screen, we are going to enter the values and then we evaluate it. So it is dynamic. Second point, only checking is done in verification. So in verification, we only check it peripherally. In validation, evaluation is done. In validation, we check whether the product built is working as intended or not. Third point, documents, requirements and code are verified in verification. So we check the requirements, documents and ensure that the product or application is designed as per it. But in validation, testing and validating the product or application is done. The input is given, the output is uptime, and the product is tested and validated. Fourth point, verification is to check if the software meets the specifications. So the customer gives us the requirements. In verification, we just check if the software meets the specification. And validation is to check if the software meets the customer expectations plus requirements. So here we are judging whether the software is meeting the expectations of the customer by validating it and also as per the requirements. Verification can hook errors that validation cannot find. Verification is done at the initial level, so it can find certain errors that validation cannot find, and these can be fixed. Validation can hook the errors that verification cannot find. So in validation, we are giving an input and getting an output. So the errors that are not found in verification are found in validation because the actual evaluation is being done here. Sixth point, verification is a low-level exercise. It is done during the initial phases and it's a low-level exercise. Validation is a high-level exercise. You are actually validating the product by giving parameters into it. So it's a high-level exercise. Seventh point, verification is done in the first stages to see if specifications given match. So during the early stages, this verification is done. Validation is done after the verification when the code is done. So after the code is written, then the validation is done by giving inputs and obtaining outputs. Eighth point, verification confirms to requirements. So verification is just seeing if the requirements match to the product or application. Validation confirms to the end usage of the product or application. It is an evaluation process wherein end usage is evaluated. The client is satisfied or not is done in validation. Ninth point, verification is done without executing the software. It's just a match of requirements in verification and no execution of software is done. In validation, the execution of the software is done. 10th point, verification has reviews, inspections and walkthrough because we are going through the requirements. So the requirements, inspection, review and walkthrough happens. In validation, smoke, functional and regression testing happens. Smoke means we just take the product or application and we just give some random values and check if the basic functionality is working or not. Functional is giving proper inputs and seeing if the outputs are obtained or not. Regression is nothing but rerunning. 11th point, QA teams do the verification to ensure that the software is as per the system requirement specification, which is SRS. In validation, testing team does the validation of the software by actually executing the application or the product. Thanks for watching the video.